My name is Betty Du Bois, and I'm a network investigator. Today, I'm going to show you how Case Technologies Pilot and the open source tool Wireshark solved one of my customers' problems. It seems they were rolling out a new thin client solution at their call center, and the clients could not download the image. They wanted to know if Wireshark could identify the problem. I knew that if I combined Wireshark with the visualization of Pilot, I could spot the problem quickly, so I headed out to the customer site. Using a network tap, I captured the thin client booting up. Working from that saved trace, let's see what the problem is. We'll start here in IP conversations. The only information I had to work from is that the client uses the FTP protocol to download its image, but then fails to boot from that image. Well, the client is able to talk to the FTP server at 10.191.134.60, so connectivity is not the issue. Let's drill down to find clues within the conversation. Drill downs are views that are filtered to what has already been selected. Perhaps they're communicating, but too slowly, and the connection is being dropped. We'll look at TCP round-trip time over time. Since our collection point was at the client, we'll use the client-server-client chart as our vantage point. Maximum round-trip time of 235 microseconds. Wow, I just think we eliminated network latency as a suspect. Let's look at top TCP ports to verify that they're using FTP. Okay, well, they're using FTP. And it seems that for the data portion, there are 3 separate conversations with approximately 5.2 meg each. Yet I know the image size is 40 meg. We're getting closer. Let's look at TCP errors overview to see if we can find the problem. Aha! Resets mean that the conversation stops prematurely, and 33 resets in just over 3 minutes. That can't be good. The question now is, which side of the conversation is sending the resets? We'll select the TCP resets bar and right-click to drill down to top IP sources. Aha! The client is sending the resets, which eliminates the server as a suspect. Now the only remaining question is why? Let's go back to top TCP ports. Since port 49155 has received the most data, that must be the download from the server. Let's focus on when 49155 is the source port. To see the acknowledgments the client is sending for that data and to find the reason for the resets, we'll right-click on 49155 and select Send to Wireshark. As we look through the client's acknowledgments, we can see that its TCP advertised window size is getting smaller and smaller. It's buffering the data versus passing it up to the application layer. Looks like 5.2 meg is the maximum it can handle, because look how the client gets down to a 0 window and then recovers, and then goes down to 0 and recovers, and goes down to 0 and sends a TCP reset. Then we see that a new conversation begins on the SYN packet and the client tries again. And we see the same pattern again. The client's window size gets smaller and smaller, and sometimes it can recover, and sometimes it can't. The culprit is either an image that's too large or a client who can't process enough data, depending on which department you work for. Another network riddle solved by combining the visualization of Pilot with the power of the Wireshark decodes. See you next time. I'm going to go type up my invoice.